All right, get started here. Good afternoon, everybody. Max Simmons here from Micas Networks. I'm the Chief Marketing Officer with Micas Networks and excited to be at OCP. It's been a good show so far. We've had some good speeches and talks from our big luminaries in the industry, which has been exciting and good to see, and lots of interesting things happening in the industry. I started off the keynotes this morning and thought to myself that I'd try to count all the times they said AI, and then after the first speaker, I decided that I couldn't keep up with the number and it got to be kind of ridiculous. But the interesting thing about all the AI ML talk is that it's great for networking, and we're a data center open networking company, and so hearing everybody be interested in expanding and needing more networking was exciting for us and something that I think bodes well for us in the future. Before I get too far into this, it's going to be kind of a joint presentation today, so I'm going to kick it off for the first bit. Then we're going to have Vishal from Micas Networks talk next, and then Robert will talk. He's from Broadcom, and he'll talk last about one of the future products that we're developing with them. So let me get started. What you'll learn today is you'll learn a quick introduction to Micas Networks and what we do. We'll talk a little bit about open networking and SONiC and why we think now is the time for open networking in data center and how SONiC can help the adoption there. And Vishal will talk a little bit about what's happening in the ecosystem. Then we'll understand what exactly is going on in that ecosystem and why it's the time now. And then finally, we'll talk about how big cloud is demanding accelerated network performance and better power consumption, and at least one product that can help solve part of that problem. And as you saw today in many of the talks, they were talking about power consumption being a big challenge with the AI models and everything coming in the industry. Oops. So first, I wanted to just take an opportunity to introduce Micas Networks. We're a new startup in the business. We've been in the business about 3-4 months. We launched in the June timeframe. And this is our Micas Networks open networking platform. And our goal is to deliver a complete solution to our customers. We have a full roadmap of products. So if you look at the circle or the solution circle, we have a full open networking set of switches on our roadmap. So we have 1 gig to 800 gig on the roadmap, products ready today. We have SONiC-based offerings. We have multiple SONiC offerings, different versions. We have also other NOS offerings that were available today. We have integration and implementation services. We have a broad set of warranties that we offer to our customers. And a key factor is that we have a strong supply chain. We're putting manufacturing in Malaysia. We're getting our first switches out of there now. So we have a supply chain to help you with getting those long lead times reduced and getting parts. And then we're enabling partners, and we're working closely with many partners like Aviz to get out these SONiC-based open networking solutions. And then, we're building or we're contributing to the Open Compute ecosystem. So we're part of the Linux Foundation. We're contributing to SONiC. We're involved with OCP, as you can see today, and also with Kobo and more. So we're trying to be part of the industry and give back. Briefly on our roadmap. So this is our open networking white box roadmap. We have 1 gig to 400 gig based products, all available today. I think I would highlight the M2 W694 128 QC product. It's our Tomahawk 5 product, brand new. It's in the center position in our booth so that everybody can see it. And we think it's a very exciting new product that's out there and ready for our customers. So we'd like you to come by our booth and take a look at that. But all these products are tested and validated with SONiC, ready to go into the ecosystem to support open networking. So one of the things about going with open networking is you need SONiC. There's community SONiC. It can be challenging, and so you need support. And we're helping customers build autonomous and controllable environments where they can take control of their own environments. But when they do that and they adopt SONiC, they need sometimes some support in that process. So we have different levels of support that we do. From basic services, we test the hardware on community SONiC and make sure that it works well and is ready to go. We're always open to looking into custom features and adding them to SONiC and helping you harden the product. And then we're also open to helping you with service down the road. And we think that's part of enabling the entire ecosystem and making sure that it's ready to go when people want to make the transition to open networking. Oops. So let's take a look at what it takes to understand how open networking is accelerating and what's happening in that industry right now. So if you look at the ecosystem that I was laying out, it starts off with the hardware. Then you have to add your open networking operating system on top of that, which is Sonic, typically. You need the feature implementation and support models. You need the hardware and NOS support services. And then finally, you need an orchestration layer. And you need all these pieces to come together. So I wanted to ask somebody to come talk about this for us. And that's Vishal Shukla, the CEO of Aviz, who's working on helping the ecosystem be ready for Sonic and help accelerate that adoption of white box networking. So Vishal, if you want to come up and talk for a couple of minutes.
Thank you, Max. I think it's audible, I guess, right? Yes, it is. So thank you, everyone. Before I get into the details of the ecosystem and how it is shaping up in the industry, I would like to give a quick introduction about Aviz Network. So in a single line, what Aviz Network do is essentially enable the enterprises for Sonic, like the hyperscalers have done it. And why Sonic? Essentially, this is the first customer-invented network operating system. And if you know, there is a property of the customer-invented technologies that they tend to stick, right? I mean, think about Kafka, think about PyTorch and technologies like this. And this is being dubbed as the Linux of networking. And as per the various calculations which these hyperscalers have done, it comes with a massive TCO saving. So what we are doing at Aviz Network is enabling this for the enterprise, essentially developing the first multi-vendor Sonic-based stack on top of the community Sonic. We are a team of around 50 plus engineers who are all Sonic experts, work around the globe with the customers. So essentially have amassed a lot of depth into various kind of Sonic implementation on various kind of ASICs. And then our aim is to provide the similar kind of customer experience which customer has been getting from past 20, 30 years from the incumbent vendors which are providing the great solutions in the industry. So let's talk about how Max sees this and from our point of view, what does it mean to end user, right? I mean, when we talk about the ecosystem, it always gets defined about from the point of view from the end user. So when we talk about the end user, there is not just one end user. I mean, if you really look at the companies which are Fortune 100, Fortune 500, or even the normal enterprises, you have different personas of the customer. There you have the executives who look for the future-proof technology and the best and the greatest. And then you have the network architects who essentially look for that, okay, I'm not going to get into any lock-in, and it is essentially ready for 10 years down the line kind of applications which will come into my network. Then you have the NetOps folks who doesn't want to just do the things on one way or the other. They want to innovate on top of the network operations so that they can efficiently manage their networks, right? And then the fourth one is the procurement, the most important one from the vendor's point of view. I mean, they don't want to have a budget spike, right? Until unless there is no new no new deployment, the budget is flat. Right? So these are the four different kind of personas, and they all have four different kind of, I would say, the things they want to achieve while doing their job, right? So essentially, Sonic fits in this bucket very nice. It's future-proof. It's essentially open, and because it is community-based, the TCO remains flat, and those kind of things are there, right? But then, what it takes for a successful Sonic deployment, right? So let's talk about the successful Sonic deployment. Let's start from the Sonic ecosystem. Now, if you go to the Sonic ecosystem GitHub, there are 100 plus 50 SKUs which are listed there for the Sonic ecosystem, right? But then that's just the SKU, right? The first thing you need is the qualification of your deployment. It could be edge deployment, it could be a simple IP class deployment, or it could be a VXLAN based deployment. So the customer want to know that it is at par with the quality with which they were deploying their Ciscos and Aristas and Junipers in the past, right? So the number one thing is the deployment qualification. Then comes the day one orchestration, that if I'm going to deploy it, first of all, will it work with my existing brownfield deployment? And the second of all, if I have to configure it, what are the ways for configuring? Does it have a Cisco kind of a CLI? Does it have the Ansible playbook? And does it have the YAML-based templates and things like that? Once deployed, then the NetOps comes into the picture, the day two operation, cost in, cost out, the visibility of it, and the manageability of your whole fabric. Then comes the part of cloud integration. Majority of the customers today, they have some sort of a cloud presence, actually most of them, right? So they look for the cloud integration from the NetOps point of view and from the manageability point of view. And towards the end, they look for the ecosystem integration, which means that it should be integrated with Palo Altos and the Zscalers and the application, which they run for their application performance management and their own VPCs for that matter, right? Apart from that, which cuts across vertical into that, customer look for the architecture planning, right? I mean, they want to know that how they're going to deploy the network, right? Which network is better for them. And they look for the enterprise-grade support 24/7. So this is what the customer look for from the ecosystem of Sonic when they look apple to apple, that I have my existing deployment and how it's going to be the existing deployment with Sonic. These are the elements which are required for any Sonic deployment to be successful, right? So what do we do about it, right? So this is what Avis does, as I started my presentation with, that our mission is to replicate the Sonic deployment in enterprises the way it has been done in the hyperscaler. And trust me, all the hyperscalers have actually gotten all those things in a very fine way, in a very predictable way, and a very consistent way, to the point that Tomahawk 5, I think they will be the first one to deploy Tomahawk 5, not just because they want just the greatest and latest, but they also have the systems in place that this can be deployed with the fastest way possible, right? So what it takes for that stack, right? So what it takes is you get a Tomahawk 5 from Micas, right? Start there, right? And then you come to us, we're going to give you the deployment qualification of the use case which you are looking for, right? So apple to apple, how many packets get dropped when the link flaps? We'll tell you that, right? And that's what is required, because if you want to have a confidence on a network that if I'm gonna replace a switch, then my application will not be having any performance impact, you need to know how many packets got dropped, right? What is the latency of it? And what is the performance characterization, right? So that's one thing. Then we have a whole suite, which I mentioned as a Sonic stack, which is called ONCE, stands for Open Networking Enterprise Suite. You use the Fabric Manager functionality of it for doing your day one orchestration. Then you do the telemetry for your day two automation. And then you have the APIs for connecting into the cloud, right? These are standard APIs which can connect with any application which you want. And the way these APIs are written is that if you have an existing layer in place from some of the existing vendors, you just plug and play. And once the data starts coming in towards ONCE, it starts to get normalized there, right? So this is one of the things on how you can have the new switch in your deployment and essentially just put it right away instead of making a custom-driven automation on top of it. And then the public cloud apps integration. And then we have the architecture help with the RDEs. We call it resident development engineer. We have the open, I would say, referenceable customers from Fortune 500 kind of customers who have done this thing with us. And then 24/7 support, which is very important, right? The SLA of 1 hour, and essentially can get the customer back, and if anything goes down in the network, and in backend work with Micas, right? For that matter, to make sure that the issue is taken care end to end. So essentially, this is what it takes. This is how it's being solved. And the another way of looking at it, is essentially from the customer point of view. They start the deploy, but the deployment happens after a lot of experimentation, which happens before deployment. We call it pre-deployment, right? Where really customer develops the trust with the technology, especially the technology which is like networks, right? So a lot of work into the pre-deployment, then a lot of work into deployment, and a lot of work after to make sure that the deployment is successful, right? So if you look at the previous slide, this is also kind of seen in these three buckets as well, right? So all I want to finish my presentation here by saying that Sonic is a great ecosystem, right? And because it is open source, because it is community based, there were gaps, right? And the gaps is being filled in that manner. So that's about ecosystem, and that's about how you fill those gaps in the ecosystem. Thank you, Max.
Vishal, where do you see Sonic being in in the next couple of years? What's your vision for Sonic?
Well, I would say that, first of all, it will coexist with the existing network operating system. And the second of all, I think the data centers, the high-speed data centers, let's say 100 gig and above, that's where you will see Sonic. And also onto the edges, because you have customers, the retail customers and everyone, they're starting to do. And one of the reasons why we'll see it, because time to market is very fast with Sonic. Pretty much every ASIC vendor starts their ASIC validation with Sonic. And Broadcom can speak about it. But this is the time to market thing which Sonic is fixing. So thank you, everyone.
Thank you, Vishal.
Yeah.
All right, so next we wanted to talk about one more challenge that involves Micas and what we're doing. But the second challenge is big cloud is demanding more network performance and better power consumption solutions. So you heard it today. AI ML is driving more bandwidth requirements, scaling up, needs more performance, but also needs a lot better power. And power is one of the critical things that we need to address with sustainability. And so we wanted to explore this a little bit and how we solve some of these challenges. And to do that, Micas has been working closely with Broadcom on developing some new technologies. And we use our joint development model. And this is our model to go faster, to build products, our faster time to market, to deliver high quality products that are designed closely with our partners. And I won't take you through everything, but we go through these different stages from concept design to product validation testing. And in these stages, we're able to develop products and deliver them quickly. And so we've done a lot of work with Broadcom to develop a new technology. And that's where we wanted to bring in Robert Hanna, our product line manager over at Broadcom, who's helping with developing co-packaged optics and a next generation switch for us. So Robert, why don't you come on up and tell us about what we got here.
Great, thanks, Max. So as many of you know, Broadcom engaged with Micas Networks earlier this year to co-develop a mini pack-based switch, which we could use, or our customers could use, to take our co-packaged optics to market. So I thought it would be helpful to provide a bit of an overview of Broadcom's co-packaged optics and emphasize some of the benefits of the technology. So at OSD, we focus on network connectivity solutions in the data center. New data center usage models like generative AI, have ever greater network dependency. This slide is not a new one, and I think some of the slides you probably saw earlier today have much larger growth projections for intra-data center traffic. But the bandwidth demand growth is regardless of the numbers you see or that will be before us, ultimately they will drive ever increasing power dissipation requirements and cost challenges in the network. Using conventional interconnect technology, these challenges ultimately will constrain our ability to deploy things like generative AI at scale. So when you think about the network requirements for AI applications, what is really needed is a sort of a step function increase in the connectivity in the data center. Higher density, lower latency, lower power certainly, lower cost, faster speeds. And what you find is that when you look at least the hardware solutions, you quickly run into the limitations of the infrastructure that's deployed today. You've got limiting factors like signal integrity, certainly power dissipation and cooling. Cost is always a real metric, and reliability is never should be undersold. It's a critical component of how people make decisions about infrastructure deployments. And ultimately, we look at things, what technologies can we use to try and overcome some of these limitations? For signal integrity, you want to reduce the channel impairments. For power dissipation, ultimately reducing circuitry, eliminating signal processing can reduce power. Going to lower process nodes and doing integration is a great way to do that. On the cost side, keeping design simple and focusing on manufacturing for scale is important for cost. And on the reliability side, it's important to focus on CMOS integration, leveraging established processes, and wherever you can't, look at using through or field replaceable components. So ultimately, Broadcom's silicon photonics initiatives that we've sort of been accelerating over the last few years. The key benefit, or I guess I should say one of the key benefits, as you look at higher and higher levels of integration, is the simplification of the platform. Here you see, a conventional module design with often hundreds of discrete components. If you look at integrating those into with silicon photonics, you can drastically reduce the complexity, simplify the design, and improve reliability. And if you take that one step further, you can actually eliminate the pluggable interconnect altogether and go with co-packaged optics. So you drastically simplify not just the transceiver design, but you can have an impact, a real impact on the switch box design and cost. So a quick overview of Broadcom's co-packaged optics platform. The key innovation is the SCIP optical engine. SCIP stands for Silicon Photonics Chiplet in Package. These are reflow attached to a package substrate in a multi-chip module, and ultimately that package substrate can be attached to any PCB or switchboard. And then a detachable optical jumper is then attached, and ultimately everything is tested and then can be attached to the system main board via a socketed connector. There's a remote laser module, which again is one of those fruable components that provides the light source to the optical engines. These are all front panel pluggable and can be multi-sourced. And then finally, to complete the solution, Broadcom's developed a firmware API which virtualizes the telemetry data to the higher level switch OS. To understand how CPO can address things like signal integrity challenges, let's look at insertion loss. More specifically, let's look at the loss in the signal levels between the switch ASIC and the optical interconnect. For both conventional DSP-based and LPO pluggable solutions, you can see in this graphic there are a lot of different areas where interference and interfaces can lead to reflections that can impact signal quality. When you compare this to the CPO solution at the bottom of the chart, which is significantly simpler, you can see the benefits there. Today, at 100 gig per lane, with careful board design, these reflections, these signal degradations can be managed. But ultimately, what happens when you move to 200 gig per lane signaling? Pluggable solutions that have been used in the past at 200 gig signaling, will lead to ultimately more signal processing, not less. Higher coding complexity with additional FEC, and ultimately higher cost and higher latency. With CPO implementation relative to these other pluggable alternatives, you can develop a switch platform that saves as much as 30% platform costs and reduces insertion loss in the channel by as much as 12 dB. Oops, excuse me. All right. Okay, to show, I guess the really important one, and the one Max was referring to, was power. And ultimately, this is the most important thing that's discussed when we talk about co-packaged optics. At 100 gig per lane today, with a module that has a 7 nanometer DSP, you can provide an 800 gig interconnect solution at about 16 watts, 15, 16 watts. As those solutions transition to 5 nanometer DSPs, this might reduce down to 10 or 11 watts. And with linear pluggable optics, where you can make that work, you might get an 800 gig interconnect down to about 8, 9 watts. When you move to 200 gig per lane, our projections for a module with a 3 nanometer DSP, you might be able to provide an 800 gig, equivalent 800 gig solution in around 9 watts, 8.5 to 9 watts, which at 200 gig per lane is starting to look pretty good. But then when you look at CPO and the advantages you can gain from that, an 800 gig solution today with 100 gig per lane signaling, you can achieve basically the same interconnect bandwidth at 5.5 watts. And this scales ultimately, the benefit scales to 200 gig. We think we'll also be able to provide a 200 gig per lane signaling solution at something that less than 5.5 watts, probably around 5 watts. And so, when you compare this to what might be on the market a few years from now, even with the 3 nanometer DSP process, we'll be saving 40% in terms of interconnect power dissipation. All right. So, Broadcom's goal ultimately is to develop a silicon photonics platform that is scalable, not just for today, not just for 1 or 2 generations, but is scalable into the future. And we believe with our co-packaged solution, we'll be able to do that. We've been able to develop a platform with the industry's highest power efficiency. We believe with the highest bandwidth density, certainly what's required in the networking case, and one that's designed for reliability and operational efficiency. Our most recent product announcements, and one we're demonstrating here at the show, is the Bailey Tomahawk 5 CPO. This is a 51.2T switching solution based on the Tomahawk 5. We're sampling this product to key customers today, and we expect to product release at the second half of next year. So ultimately, as I said, Micas has been instrumental in helping us develop a platform to go to market with our CPO. The MiniPack open switch platform. CPO, again, minimizes the channel loss. It buys you 30% in terms of power reduction. It simplifies the system board and ultimately lowers costs. And the integration of the CPO and CMOS with the field replaceable RLMs, again, will address any issues with respect to reliability. So it really does cover all 4 bases in terms of signal integrity, power dissipation, cost, and reliability. That's what I had. Go ahead.
Thank you, Robert.
Thank you.
That was great. So that's some real power savings there with performance. And this is a demo that we have at our booth today. So real quick, just to wrap up, you can see all these things at our booth right now. Aviz has a demo at our booth, which is very exciting, in our server rack. We have the CPO demo, and then we have a switching station, a Tomahawk 5 400 gig, and a distributed aggregated chassis demo. So please come by the Micas booth, and thank you very much for the time today.